So welcome you all to the first lecture of the torsional loading. So in this first lecture, we are going to cover some basics regarding this course. So first of all, we are going to study the sign convention and twisting moment, and at last we are going to see some example. Actually, one example only, and after that we will wind it up. So let's start. So first of all, what is a torsional loading? So let's consider a cylindrical bar here. We will take one cylindrical bar and let's take the longitudinal axis. This is the this is the longitudinal axis, and we can say what is a torsion. So equal and opposite couple acting about longitudinal axis is called torsional loading or twisting. So let me write the definition. Equal and opposite couple acting about longitudinal axis is called torsional loading or twisting. So we can represent the torsional loading in this fashion, that is equal and opposite couple. So this is suppose clockwise and this is anti-clockwise. So this is the representation of the twisting moment. Now coming to the sign convention, like which sign convention we are going to take as a positive or which torsional loading we are going to take as a negative. So first let's come to the sign convention. Sign convention. So first of all, let's take a cylindrical specimen, and this is the longitudinal axis. Now take your right hand and curl your hand. First of all, you have to take either side, that is either you have to take this side or either you have to take this side. You have to curl your hand in any one direction, any one side. Either you choose this side, either you choose this side. Suppose the twisting moment direction is given by this. Or in this on left hand side in this direction and right hand side in this direction. So take your right hand and curl in. First take the right hand side direction. So if you're curling in the direction of the arrow, then you will see that your thumb goes away from the cross section. So if your thumb grows away from the cross section, then we treat it as a positive sign. So let me write. First use your right hand, and curl your hand and curl your hand. If you're curling on the right hand side, and if it goes away, if your thumb goes away from the cross section, then it is positive sign, positive convention, positive sign. Now take one more specimen, cylindrical specimen. This is the longitudinal axis, and suppose the direction of torsion on right hand side is given by this thing, and on left hand side the opposite nature, so in this direction. Now take your right hand and basically take this section. So take this section and curl your hand, so right hand, and you can see that your thumb is pointing towards this specimen, inside this specimen. Thumb is going inside this specimen or pointing towards this specimen. So this sign convention we take as negative. Now how to evaluate the twisting moment as at a section. So twisting moment at a section. So the concept is either side. So you have to take the other side, summation of the other side. We have to take the summation of the twisting moments, with sign convention on the other side. That is, either take right hand side or take left hand side. We will see, don't worry. So we can write that it is the algebraic sum of all the longitudinal couples acting on either side of that section. So let's take one example. Let's take one case study. So suppose this is the specimen. So this is our specimen, and we have sections here. This is x1 section, this is x2 section, and this is x3 section. And the direction of the twisting moment we can represent it as suppose in in this section we have 750 Newton meter, 750 Newton meter twisting moment, and here in this direction we have 3000 Newton meter. Like before this section we have 3000 Newton meter, and here we have 400 Newton meter, and in this direction we have 1850 Newton meter, 1850 Newton meter. So we have to calculate the twisting moment at the section x1, x2 and x3, and we have to also plot the twisting moment diagram. So if you are considering this section x1 here, so this is the section, so either you have to take left hand side or either you take right hand side. So on left hand side you are seeing only 750 Newton meter, so take your right hand and call in the direction of the moment. So you can see that your thumb goes away from the cross section, so we can say that at x1 we have positive twisting moment, that is from left hand side, from left hand direction, left hand section direction, like from this direction, we have the positive twisting moment of 750 Newton meter. Now if we take right hand side, suppose if you are considering this section, like this whole thing right hand side, then suppose we have here 3000 Newton meter, so take your hand and it's saying that our thumb goes away from the cross section, so we have positive from right hand side, we have positive twisting moment, and other we have here 400 Newton meter twisting moment, this thing. So call your hand, so we can see that our thumb goes inside the specimen, so it is negative twisting moment, it is minus 400, and minus here 1850 millimeters. Again take your right hand and curl in the direction of the twisting moment, so we can see our thumb is pointing inside the specimen, so it is also negative, that is 1850. So the net moment is plus 750 Newton meter. So left hand side equal to right hand side, so you have to consider only one side, that is at the left hand side or right hand side, and you will get the same results. So it depends on you that how fast you are going to calculate everything. Now let's calculate at the section x2. So if you are going to calculate at the section x2, x2 from left hand side, see, so at section x2 from here, this is the left hand side, so from left hand side take your right hand and consider the twisting moments. So here first is 750 Newton meter, so it's going outside, so we have plus 750 Newton meter, and we have also 3000 Newton meter twisting moment. If we take your right hand and curl in the direction of the twisting moment, then we can observe that our thumb goes inside the specimen, so it's minus 3000 Newton meter. So the net twisting moment is minus 2250 Newton meter. Now similarly for x3, so if you are going to consider x3, so the fastest way is to calculate. So fastest way to calculate, either take left hand side direction or right hand side direction, but the fastest way is to take right hand side direction because we have only one moment. So take your right hand and call in the direction of the twisting moment, and we can see that our thumb goes inside the specimen, so we are getting minus 1850 Newton meter, the net twisting moment. Now if we are plotting the twisting moment diagram for these sections, so with respect to the distance, so this is the curve, and in this direction we have x, this is the distance or length, and here we have twisting moment T. So we have three sections. So we are going to divide into three sections. That is, this one is up to x1, x2, and x3. So for first section, we got the moment as 750 Newton meter. So we have positive sign. So here, this is the positive sign. This is the plus 750 Newton meter. This is the plus 750 Newton meter. If we are considering the section 2, that is x2, then we got minus 2250 Newton meter, that is negative. So we are going to get the negative twisting moment here. This is minus 2250 Newton meter. And if we are considering the section x3, we got negative twisting moment, that is minus 1850 Newton meter. So slightly above. So this is minus 1850 Newton meter. So this is the representation of the twisting moment diagram. So this is the twisting moment diagram. So this is all about the first lecture. In the second lecture, we are going to focus on how to evaluate load, nature of stress, distribution of stress, magnitude of stress, and maximum value of stress and its location. So that will be the main objective for our second lecture. So for now, thank you.